The figure from the previous clip had points P, Q, and R at the corners of some parallelepiped, or, and we can assume coordinates for these corners, any coordinates really. So let's just suppose that our vector PQ has components -3, 6, 5, and PR has coordinates -5, 6, 7. And let's see what we can conclude from those coordinates. In the first place, we're out of focus, and I really have a lot of trouble keeping this thing in focus. Let's see if we can come back here so we don't have to start all over again. Okay, PQ has a magnitude equal to the square root of 3 squared plus 6 squared plus 5 squared. And I haven't added those up, but that's 36 and 25, which is 61 and 3. So that's square root of 70 in case we need that. And PR is the square root of 5 squared plus 6 squared plus 7 squared. That's 25 and 36, which is 61. And then 49 is going to be 110. And if I've done my arithmetic correctly, that's going to be the square root of 110. Now, what's the vector QR? Well, to find the vector QR, we can consider the fact that, and write this off to the side, that PQ plus QR equals PR. So, QR must equal PR minus PQ, so that QR is going to equal PR minus PQ, which is going to equal what? Well, PR has an I component of -5, and PR has an I component of -3. PR minus PQ will have an I component -5 minus -3. And it'll have a J component, which is 6 minus 6, and a K component of 7 minus 5K. So that's going to equal -2I plus 0J plus 2K.